people, so I will start that up. So good afternoon, everybody, and welcome to this webinar on manufacturing with a difference. So far, we have heard themes like design-led manufacturing and Make in India. We wanted to actually take that up with a slightly different approach, and that was on market-led manufacturing. More on this as it will evolve. But the fact of the case is, as we learned over the decades, what we learned in our first year at our management course was that you can never go wrong if you start with a customer. And we do believe that if we have to succeed, we have to start with the customer. It is important to understand what the market wants and design for that market, design for our manufacturing, and then that market-led manufacturing is actually what will stand us in good stead as we execute for success in the marketplace. So without further ado, let me have the privilege of introducing my fellow panelists on this group. And I would like to take the opportunity to start with Mr. Amrit Manwani. Mr. Manwani is a well-known, business leader in the industry. He is actually an engineer from IIT Kanpur with his MBA from FMS University, FMS Delhi University. He has served in multinational companies like Larsen & Toubro and General Electric before he started his entrepreneurial journey. And he is now having a thriving electronic hardware industry with multiple plants in India and abroad. He has received several awards to his credit. He has been engaging with the industry, driving the industry thought leadership as a past president of Elsina. He is also the chair of Elsina's, he's chair of Elsina, and under his stewardship has shaped up the EMC cluster in Bhiwadi, where he has also spearheaded India's first OSAT, the Sersa Semiconductors Private Limited. Sir, it's a pleasure having you on board, and I will take the liberty of moving on to my other panelists. So also on board, I have Ma'am Savita Kashyap, Senior Director, Embedded System from CDEC. Now, Savita ji is a veteran with 23 years of experience in design. She is an MS Physics and MTech CST from IIT Roorkee. So if Mr. Manwani and I have MBA from FMS University in common, Ma'am Savita, both of us have done MSc Physics from Delhi University. Okay, and right now she's handling very prestigious projects at CDEC. She's been driving NAVIC, which is India's first GPS related initiative. And she's also been engaged on smart card technology. And this, again, will be something which can play a pivotal role in developing a strong luring of an India fab by and by. We also have Dr. Anuj Grover here. Dr. Anuj is the head of the Center for Intelligent Product Development at IIIT Delhi. He is also an industry veteran. He was with ST Micro. He obtained his PhD from IIT Delhi in 2015. He is MS in Electronics, Circuit and Systems, and a BTech from IIT Delhi. He is, he's an innovator at heart. When you interact with him, you'll find him approaching ideas from the point of view of the market, and he's driving that innovation culture in the academia. His Center for Intelligent Product Development is definitely a place that we should all visit. to understand the scoping of his work. He's actually earned 15 patents already. And beyond these 15 granted patents, there are 10 more patent applications which are in different stages of filing from idea disclosure to final approval. So a pleasure having you on board, Dr. Anuj, and we look forward to hearing from you shortly. And finally, I must introduce a young colleague from Ministry of Electronics and IT, Mr. Nishit Gupta. He's a director technology at ISM and a scientist EMIT. Nishit and I have been actually engaged over the last decade in different fora for enabling the R&D environment in the country. He and the Mighty team are doing seminal work in broadening the microelectronics research. He is one of the thought leaders shaping the execution of the Chip to Startup program. And collectively, they are nurturing the fabulous chip design ecosystem in the country in an absolutely outstanding manner. And of course, we will be inviting him to talk of it later in the program, because that is going to address the design piece in the final, manufacturing programming. He also has a prior industry experience at ST Micro, where he was there for over a decade. He is an engineering graduate in electronics and comp stream from University of Delhi, and also has an MTech in computer science. So, I am really blessed with an eminent set of panelists. I'll round off the introduction for this with my own brief. I'm Dr. Ashwini Agarwal. I head the electronics semiconductor SIG at Elsina. I'm also the director of government affairs at Applied Materials. I am also the chair of the Sector Skill Council at Electronics Sector Skill Council. And I have over 40 years of work ex at this point of time. I have been the past chair for numerous associations and industry committees. My technical background is I am an MSc in physics with the specialization in advanced devices and electronics. I am also an MTech in electronics and communication with VLSI training. I have a PhD, and I'm also a fellow of Institute of Electronics and Telecom Engineer, and an IEEE member at this point of time. I look forward to working with all of you on this panel. And on this note, if Mr. Manwani is open, sir, can I start the ball rolling with you?
Yeah, thank you very much, Dr. Ashwini. Thank you for the kind introduction. And very good afternoon to all my co-panelists, as well as all the audience who are there in this webinar. It's a pleasure to be interacting and sharing my experiences in the electronic industry, which is not an easy industry, particularly from a manufacturing standpoint. But having weathered several decades of ups and downs in the industry, it's gratifying to see that the electronic industry is now maturing to a point where there is tremendous potential for growth. And as the topic of today's webinar, it's so relevant because, as Dr. Ashwini, you earlier mentioned, that customer is the king. We have to look at customer needs, and similarly, we have to focus ourselves towards what the market requires. And if we see over the last decade or so, typically, particularly in electronic manufacturing, where has the manufacturing developed a maximum? If we look at some of the sectors within electronics, it's the mobile phones, which were the first kind of product to take off in a major way. Because the industry addressed that market, look at what the good results that the industry has achieved. Today, from being a complete importer of mobile phones, we are exporting mobile phones worth almost $10 billion, and it is expected to grow many-fold in the next decade. Similarly, if we look at other sectors like IT hardware, automotive electronics, telecom, electric vehicles, data centers, IoT products, etc. These market segments are likely to provide the industry tremendous scope for growth. And therefore, it's very clear that we have to focus on what the market wants, both domestically as well as globally, and we have to focus on that. And similarly, we have also to look at designing products which cater to these market segments. Dr. Ashwini also mentioned about our company that we have gone into semiconductor packaging, and we have set up this unit in Bhiwadi, Rajasthan. And there also, our main focus has been towards what is required from the market. And if we look at the market in India, there's a huge market for memories, and therefore we have focused more on the memory side of semiconductor packaging. But nevertheless, there are others, domains within OSAT packaging where there is tremendous potential. For example, we are also looking at designing and developing an LED driver chip in India, which will be used by majority of this segment. As we know, there's a requirement of about 100 crore LED drivers in the indoor lighting segment, and that could be addressed if something like that is available domestically. Similarly, there are other products in the OSAT domain like RFID, smart meter devices, sensors, IoTs, and several other matured standard packages that we could address at. So, in a nutshell, what I would like to say is that we have to focus both in EMS, in not only in OSAT, but also in component manufacturing. What does the market require? And therefore, depending on the market needs, we have to look at designing aspects of the components, designing aspects of the variety of semiconductors and other components, which would lead to definitely India becoming a manufacturing hub, not only for Indian market, but also for the global market. With these initial comments, I would like to hand over back to Dr. Ashwini. Thank you very much.
Thank you, Mr. Manwani. Team, I am going to be sharing my screen for a quick presentation overview on how do we capture the semiconductor demand. Some thoughts on it. Can you see my screen?
Yes.
Okay, great. Then I'm just going ahead. This is actually a common theme which has been there that I have been talking about for the last several years. And I'm extracting a presentation of August 20 and adapting it for today. And the key messages are very simple. We have to design for manufacturing. We have to design for markets. Okay, that is the need at this point of time. We need to have a strategy if you want to capture India's semiconductor demand. You must realize we are investing such big amounts, 150,000 crore worth of fab investment is on the anvil at this point of time, and we're likely to have more post the elections as we gain momentum in the semiconductor sector. If this investment is to hold, and have value as we go ahead, we need to make sure that these projects succeed. If these projects have to succeed, then we need to make sure that they are having the right loading and they have the right yield. The two things on which the success of any factory rests. is that it should be able to have a good demand load, okay, and that it is not under capacity on that front, and that it has a good yield so that the ROI is maintained. Now, in a market where you are competing with established players, where there are cutting edge nodes, how do you survive? And you have to plan for it. You have to strategize for it. You need to select products where that node size is not a constraint. So perhaps we do not have to go for the cutting edge node. We need to select products and applications where a relatively longer life node can be there. We can leverage our policy and industry instruments to capture that market. So if you do that, you have more than a fighting chance to survive in this industry, which is in itself a very competitive industry globally. So like what we have suggested earlier was try and leverage positions. You should look at India market as an opportunity, but think big. But you should definitely look at opportunities with which you can secure India market. Look at opportunities where you are able to build in security, because that is the WTO compliance. If you have a security element with which you want to secure your product, yes, that is permitted under WTO. Similarly, healthcare is again a design element. If it is taken care in our portfolio selection, we can make sure that their particular chipset could have a future from India and take allied markets as well. So we need to take cognizance of it. We need to create a unique semiconductor chip portfolio with that Indian IP that can be incubated in an India fab. When I say India fab, it will also mean India ATMP. It will also mean the downstream EMSs, which will actually leverage it. That's the thought that we have to build with. Okay, then you can aggregate the demand with an appropriate, programming to build a loading onto the India fab, and that is very critical. Just to give you an idea, next doors to Mr. Manwani is a factory called Idemia. It is Asia's largest smart card, packaging factory at this point of time. That smart card factory is packaging 70 crore cards a year. Okay, if you can actually capture that chip demand for it, which is coming right now from UMC or SMAC or wherever in internationally, if you could capture it, that would give you a loading for about a month on your fab here. Not much, a month. Okay, and that is what you have to do. Capture such huge demands, and that is the sort of loading that is being talked of. So we had at that earlier era looked at a few options. We said automotive, don't go aggressive against four-wheelers. That's the big sharks are floating in that. Can you capture the two-wheeler market in India? That's India's the largest two-wheeler market in the world. If you could do it, maybe what you do now would be a reality a few years down the line. That could be a potential market of a 30 million two-wheelers in the country. If you select a few chips from this table that is there, a few chips, as simple as a simple collision sensor chip itself can proliferate into huge numbers. Your NAVIC chip, ma'am, can proliferate into huge numbers if it can be appropriately developed. And if you had three chips that go into every two-wheeler in the country, that would be a 90,000 wafer starts per annum loading. That would be almost a third of loading of your of your fab demand. Okay, and I'm just pointing out, actually, that's how the big thing it can be. How can you use a simple collision sensor with some security reference to it? Imagine a helmet with a collision sensor, which triggers a response if there is an accident on the smartphone to an emergency response team. Put it up on a cloud blockchain or whatever mechanism, link it to a secure mechanism. Your RFID readers, they're on the cars. Can we bring it into the two-wheeler? Can we work out applications that link it to location? Two-wheelers are one of the highest prone stolen item in the country. Can we do something where we link it to security and start locking it up? Okay, we have to be very creative how we want to do it. We need to lock our payment systems with our security stacks. And we need to see what other opportunities are there. In 2017, I kept this up. In 2017, we had looked at set-top box. That's gone. As time rolls by, the application will roll. We have to see where it makes sense. In 2017 to 2019 timeframe, set-top boxes, they were still an opportunity. Now they have gone, but we can look at other opportunities. In that era, we had projected that we could get about 240,000 wafer starts if we looked at select earlier Carroll strategy products. But we can get other opportunities in healthcare, in other areas. It is for us to creatively mine it. And therefore, the key message here is very clear. Create a chips portfolio from an India chips program. That's not a spray and pray program. I think, Nishit, if you can hear me, my recommendation would be that you should now start focusing on the chips that you want to make. The chips that you can lock in for your India fabs, with your India specific lock in it. Okay, that would be very critical. Okay, maybe now you don't need the item 3 of incubating in a virtual fab stroke ATMP, but that is good. If you can look at an appropriate design to market aggregation strategy, that will be the key success factor for manufacturing. And on that note, I finish. Let me bring it back to academia. Anuj, you heard me. You're smiling. What do you think of this?
Okay. So, am I audible?
Yeah.
Perfect. So, thank you, Dr. Agarwal, for bringing in these key insights. And I strongly believe that this is the way to go, in the sense that uh, India today cannot really look at competing with the market leaders in 3 nanometer or 7 nanometer technology nodes. Those are highly capital intensive nodes with a huge risk of failure involved in them. And a huge volume would be expected to even mature those technologies. And I think this is also very much in line with the fact that MeitY today has chip to startup kind of programs where they insist that academic institution would tie up with some industry partner which has a product in mind and they co-develop that product. So this chip to startup program that Nishat will probably talk about more already talks about engaging industry and academia together so that we have market driven designs. But I really liked your idea that while today this program uh, you know starts with someone coming up with an idea that okay, I want to develop this product whose market need or commitment from the prospective buyers is still in doubt. It could be very interesting to say that okay, MeitY says that we want to have uh, three three chips developed around NAVIC solutions, for example. They could be given the same specifications, developed at 3 different universities, along with 3 different go-to-market partners or manufacturing partners. And in this way, we are kind of mitigating the risk of failure that would come when the chip is designed in a in the country for the first time or in a academic setting or with players who are not very experienced in the market yet. Because most of the Indian players today already use chips developed and manufactured by others. So I really like that idea also. I would also want to highlight what we are doing at Center for Intelligent Product Development, where what we are saying is that uh, we we cannot wait for Indian chips to come into the market, to be available in the Indian market, to start developing products. Because once the chips become available, they will be available in thousands of numbers. And if we do not have a product value chain, a product line already ready, which can adopt those chips quickly, uh, we will just not be able to load the fabs. So product development work also has to start hand in hand simultaneously. And I agree it has to be a part of national semiconductor mission somewhere, where we say that it is not just chip development, but also product development, electronics product development, intelligent product development, where once the Indian fabs start to churn out chips, these products will just simply lap them up, and the loading of the fabs would be higher. So CIPD is focusing on that aspect, and we are working on developing ecosystems, adding more functionality and features to products. Uh, I was looking at BLDC fans, for example. Today, BLDC fans, if I go to the market and ask this, a regular retail seller about what is the benefit of using a BLDC fan. So for me, I've worked with ST for more than 18 years, and I know that BLDC fans are much more energy efficient. So that is pretty evident from the user specification that they give. But what they tell us is that, oh, sir, once the motherboard goes cranky, then you have to replace the fan. You can't do anything with it. So at CIPD, one of our key objectives is also to bring in repairability. When we develop products indigenously, when we develop designs indigenously, repairability and reuse is something that we have to build in. And that is also one of the key focus at CIPD. And I believe configurability and ease of transition from one ecosystem to another, that is a platform kind of an approach, is something that is needed. And that is what we in Triple IT Delhi, especially in the Center for Intelligent Product Development, are working on. Uh, Market-led, one more thing that I noticed is that while uh, for semiconductors, there could be some reports which are available about this particular market is this billion kind of opportunity in India, or this particular market is this kind of opportunity in India. What I did find a dearth of was that there are not many market surveys or market reports which tell about what should be the features in products. For example, if we talk of a water pump, what kind of features would you want in a water pump 2 years down the line or 5 years down the line when we talk of an Indian ecosystem? For example, a large population in India suffers from uh, or drinks water which is contaminated with E. coli. Uh, should we not have some sensors or some mechanism to tell a user that, okay, please put chlorine in your tank so that E. coli infestation is managed? Large swaths of India, because of a huge amount of groundwater extraction, also gets hard water. An electrical appliance which would live for 10 years vanishes within 1 to 2 years just because of that hard water. There are solutions in the market, that is to put softeners in the overhead tanks, but there is no way to track them. Can a water management ecosystem not do that? So there is very limited insight into what the market needs, or how the market should evolve over time. And this is very, very important when we talk of products, final products which go into the consumer hands. And I think that is also one thing that we need to develop. And at CIPD, we are trying to do market surveys and, uh, you know, extrapolate what would be needed in the market in the future. And we believe that we can help industry partners who we engage with to, enhance and develop their products to become future ready. So that's what we are doing in academia for now. If there are more questions, I will be happy to respond to them. I bring it back to you, Dr.
Anuj,
Ashwini.
Anuj, it's a beautiful thought you have said. What will be the future products that can be there to serve the needs of the customer? What are the latent features that we need to build in? I've just taken an example when I talked of with respect to manufacturing, what could be a latent feature that could be there. But market is the true arbiter. So beyond that, we should also see what are the innovations that can be brought in. I mean, I can have a pen here, okay, and this pen can be something simple where we are actually saying this is just going to write, but to add additional features that it becomes a pointer, that it becomes a screwdriver, that it becomes a LED light. Oh man, we are actually expanding the concept of a pen dramatically. Okay, and that is what is needed to create value for the customer. So we'll come back to this thought separately, but let me now shift gears and reach to our government leaders here. And ma'am, I know I should start with you, but let me actually first take Nishit in the logical direction, because Nishit is leading the chip to startup, and the and his interventions on design front are going to be path breaking for the nation. So back to you, Nishit. The floor is yours. Let's hear from you.
Sure. Thank you, sir. And let me just quickly highlight that I have had a privilege of working with all of you in one way or another in the past. Or maybe with some of you, we are going to work in the coming months, like Sahasra and Kipalari Delhi, right? So thanks for having me here. So what I understand is that the overall agenda, as I understand, is here to decode the overall $1 trillion opportunity in the electronics manufacturing space, and the huge $600 billion semiconductor market, and how the India can do that. Now, this semiconductor market is generally perceived differently by different audience. So, for example, I mean, one way of looking at this market is the semiconductor chips that it produces, and accordingly, we may say that the semiconductor market is broadly divided into logic, memory, analog, optoelectronics, sensor, discrete devices. Now, the other way of looking at the semiconductor market, CMOS part of it, the compound semiconductor part of it, and similarly the other areas. Now, many people may claim that the compound semiconductor is going to replace the silicon for high power and high frequency devices. However, the fact remains that the silicon is going to drive the industry for this reason for at least next 1 or 2 decades. Now, the other way of looking at the semiconductor market is as business vertical. For example, the fabless chip design vertical, which is further divided into the EDA, IP, and design, semiconductor fab vertical, the packaging and DMP and equipment. Now, again, the fact remains that the fabless chip design area has been continuously driving and taking about 30% of the overall revenue of the semiconductor value chain. So you look at any semiconductor product, I mean, the 50% of the BOM cost comes from the fabless and the IC design. And also in terms of value add, design and architecture contributes most significantly. So broadly today, I mean, we are discussing here is this special area which actually adds most significant value to the overall ecosystem. So let me quickly share my screen just to give you the glimpse of the Semicon India policy and other initiatives very quickly that Government of India has initiated just in the last couple of years, in addition to many other ongoing schemes and programs. So I hope my screen is visible here, right?
Yes.
So I think we all are aware of that the Government of India has announced this $10 billion worth outlay Semicon India program to catalyze the overall semiconductor chip design ecosystem and manufacturing ecosystem in the country. And the other aim is to, I mean, cater to the requirement of and $1 billion overall domestic semiconductor market in the country in the next 1 decade. So the incentive says that that 50% of the overall outlay of the project in different areas, which includes semiconductor fab, display fab, ATMP, and compound semiconductor, will be given by the union government. Another 20% will be given by the state government, and the remaining 25 to 30% will be given by the applicant. So you can see that, I mean, there's no other policy across the globe that gives you 70 to 75% of the overall project outlay that is being given in the Semicon India program. And the success of it actually with the fact that, I mean, the 3 big applications has been approved in the last 1 year, as well as, I mean, a number of design applicants are being approved in the rolling basis. So one of the main ingredient of this Semicon India policy is the design link incentive scheme, wherein we are giving the 3-tier support. One is the design infrastructure support, which is coming in terms of the support for the state-of-the-art ED tools, like ED tools from the Cadence, Mentor Graphics, I mean, Siemens EDA now, and then Synopsys, as well as we have also tied up with the other leading vendors for RF key sites, then ANSYS specifically for the power and other SOC aspects. So they all have teamed up to provide support to the academia and the industry. So in the designing incentive scheme, we are also giving the support for the 15 crore rupees for the chip design activity, as well as another 30 crore rupees for the support for offsetting the market visibility in terms of the PLI, production link incentive. So I'm just quickly skipping the slides, I mean, in the interest of time. So we have also set up the Chip-in Center at CDAC Bangalore, which is acting like a one-stop center for the chip designers across the country, where we have teamed up with all the ecosystem players like IMEC, Xilinx, ANSYS, Mentor Graphics, again Siemens, and Keysights. and providing a variety of supports, which does not include only, I mean, this ED2 support, but also the support for the uh, uh, integrating the designs in the MPW manner and sending it to SJ Mohali. And then we are also trying to basically team up with the other demand aggregators like Rapid Silicon and IMEC to figure out that how this chip center can enable the fabrication support at foundries. So at present in DRI scheme, roughly 11 sub startups have been approved for support of financial up to an outlay of rupees 15 crore, as well as about 20 startups are actually accessing the ED tool grid that is set up at the Chip-in Center. So, and this support for ED tool is being given on the rolling basis, and we also have the applications for products in the pipeline, which mostly will be approved within this 1 month time frame. So, I mean, coming to the point of the discussion here, that the Chip to Startup program, which is primarily targeting the academic audience. So this program actually is the fourth phase of the SMDP program, which has been there for the last 25 years. In fact, it's kind of the longest running program in the history of government, because it started in year 1998 with only 19 institutions with an aim to train only 9,500 students at BTech, MTech, and PhD level. Then in SMDP2, we targeted the 32,000 colleges, 32,000 students, and then in SMDP3, which ended in 2021, we targeted about 50,000 students and end up, I mean, generating 73,000 students. And then the current phase, which is the Chip to Startup program with an outlay of 200 rupees, it actually is catering to the requirement of 113 organizations at present, and we are slowly increasing the organizations on the rolling basis. So the overall aim is to generate the 85,000 manpower at BTech, MTech, and PhD level, and to generate 175 ASICs, 20 SOCs, and roughly 30 IP cores, which can be used by these academicians. So again, we have tied up with the SCL that all the designs will be integrated by the chip center and send it to SCL in the MPW manner. So you can see here the broad breakup of the Chip to Startup program, where we have almost covered all the states, including 28 states and 4 union territories, 9 northeastern states, 6, I mean, women and minorities, 97 academic institutions, 3 R&D organizations, roughly 13 startups also. And they are all in process of developing 1 or 2 chips for various applications. So there are total 70 R&D projects in consortium mode that have been funded for the next 5 years. So, I mean, for some of the colleges, they have started doing the tapeouts, and we are expecting a good number of tapeouts starting from the end of this year or next year. So this is the overall, I mean, scheme of things that we are running at present. And in addition to that, I mean, as Ashwini sir already mentioned, right? I mean, we need potential, where maybe Savita madam will talk about the Navik area, which was the prime area of strategic importance as well as the civilian use. And the MIT has floated one tender with the support of CDAC. And we are targeting a requirement of 16 lakh ASICs in the area of Navik receiver. And at present, we are also trying to figure out the other high potential areas like the POS terminal, as Ashwini sir already mentioned. And then the area of e-passport is also been under consideration, because you can understand that there's a great demand of e-passports in the country. I mean, running to about 4 million in quantity. So that is also being discussed. And in addition to that, LED driver chip is again a great area of interest to us. And we are figuring out how to roll out some kind of expression of interest to invite the industry players to develop the LED driver chipsets. And then again, the BLDC fan controller, image sensor chipsets, all those areas are also being figured out. Maybe in the next 1 or 2 months, we will figure out some way to engage with the Indian companies so that they can participate and kind of create a good Indian ecosystem story. Thank you very much.
Nishi, that is great. Amazing presentation. A question back. How are you looking at building it, some unique thing with which you can protect that chip from the global competitive waves? Are you looking at it? Will you try and build that in as one of the from the developing committees, developing teams?
So if I understood your question well, you're saying that what is the unique value proposition that we are trying to bring in for the Indian chips that we are targeting, right?
Yes, but not just latent needs for the market, but also latent needs for enabling an India market unique position for that.
Perfectly right. So, in fact, see, for example, I mean, you might have heard about the recent notification in the area of CCTV. So, MIT has just now announced the notification that any CCTV procurement now has to go through a qualification of Indian BIS as well as the STQC standards. Right. So now we are also trying to figure out that how this CCTV camera market can be captured in the country by way of collaborating with the majors like Qualcomm as well as the Indian players like, for example, CP Plus and Indian companies who are actually making the chipsets. As a process of staggered manner, we are also figuring out to roll out some kind of PMA, potential market access, or PPO, in these areas which are of high strategic importance. Similarly, in case of Navik also, in the next 1 month, I mean, we are actually targeting to figure out that how this potential market access can be brought in to the indigenous Indian vendors who have made the Indian chipsets to capture the Indian market. So that is the obviously first target. But then again, we also understand that targeting Indian market is just not the only requirement, and we cannot create a global companies with that.
Yeah.
So obviously, I mean, we are trying to figure out how this all scheme of things like DLI, PLI, and other, where we can give additional incentives to the companies which are actually taking the benefits in the PLI scheme to get and actually take and acquire and make use of the chips that are being designed by the other scheme of things like DLI and the R&D schemes. So these kind of connections will be established in the next half a year, and we'll figure out some more schemes to actually create a connection between the ecosystem partners. I mean, starting from the IP designers to the chipset designers to the ODMs to the OEMs.
Sounds great. We'll come back to more on this when we discuss takeaways or key actions from this. But at this stage, let me invite Savita ma'am. Ma'am, CDEX playing a pivotal role in enabling the skill capacity in the country, in driving some of the tech waves. Can we hear from you what you're doing and how it can help enable market-led manufacturing in the country?
Thank you, sir. So in CDEC, we are working on various domain. Like for me, I'm working in embedded domain for a smart card technology. In that, we have developed a smart card operating system. And this can be ported on any chipsets. Right now, we are using the chipsets which are coming from the outside. As Nishit mentioned, like electronic passport is the requirement. So in that also, so we are working with it. So there is a requirement. As you have told, smart card chips are required, even POS terminal chips are required. So I fully agree with you. These are we have to look in which kind of chip is required, sir. So from a DLI point of view, CDEC is working as a nodal agency for implementing the DLI scheme. And in that, like for market lead designs, there is a requirement of infrastructure required for design support. So in that, concept of chip-in has come, and CDEC Bangalore has set up a chip-in center for chip designers across the country. And this center is providing the support for three kind of things for accessing the EDA tools. Already EDA tools are available from various EDA vendors like Cadence System, Synopsys, and other vendors, Mentor, and NSS, Xilinx, all these are available, and providing these access of these tools to all academia, startups, virtual, in a centralized way, sir. And other thing is for providing the facility for fabrication of a chip. So in that, CDEC is creating a repository for proven designs and IPs, so that it can boost the domestic chip manufacturing, basically, sir. And yes, sir.
I think CDEX doing an amazing work.
Yes. So from a scaling point of view, CDAC is having various courses. It's for basically for students and professionals. For students running from a university programs like MTech, MCA, in various domain in VLSI and others. For a PG Tech courses as per the industry demand, basically, sir. Like PG diploma in embedded system, in VLSI design, and in artificial intelligence. So all these kind of running for the students who have passed engineering and they have not got their job, so they can do these short-term courses, basically, sir. For other kind of, for a professionals at a corporate level, CDAC is for scaling up their skills of a government employees and nail it, and others for MIT also. They are running the various courses like in a cloud computing, big data, AI, collaborative electronic manufacturing research, cyber security, VLSI design, embedded system, and concepts on quantum computing and communication. So CDAC is already playing a key role into that, sir. That I want to highlight one more thing here for a market lead manufacturing, for like for a smart card chips and other, there is a requirement of a certification, basically. So this requirement like a EMV certification is there, EL certification is requirement is there, fifth certification requirement is there. So we need to work into this area also. Then only, because these certifications are normally available, done through the outside country. So this need to be set up in India also, sir. As per my experience, this is also a need of the hour, sir.
Yeah, I sort of echo that. But to summarize, ma'am, I think CDAC's chip-in program, the chip-in center that you are implementing for MIT, I think that's doing wonderful work in being a backbone for our EDA access to academia. And thoroughly applauded. I think your short-term courses are recognized in the design industry, and I think again that's a big leap forward. Certifications for the chips that are getting made, that's a big need. I don't know what scale, what additional needs to be added to give you teeth on it, but we can discuss that in a separate forum. So I think we've taken the views from everyone. Let me just ask everyone to give key asks or a takeaway, one task, one ask, or one takeaway for enabling the future of manufacturing that you want to leave for our audience here now. Let me start back from Mr. Manwani.
Okay, yeah, thank you, Dr. Ashwini. Actually, I would, like to have three asks, not one, from an industry perspective, because it looks like I'm the only industry representative today on this webinar. So three asks are, firstly, the government of India through MITI has done a wonderful job by announcing the scheme of DLI, but that is limited only to semiconductors. What I would like is that, that scheme may be extended to other, domains like product. If somebody is designing a product which is specific to the Indian market, that should also be encouraged. So there must be some kind of an incentive, government in aid could be designed so that, I'll give you an example. For example, the motherboards for a desktop or for laptop or for tablet, if somebody were to design it here, if that entity had some government funding, it will help the industry and help the country, because today all the motherboards for these IT hardware devices are imported completely from outside. So that is one ask. The other ask is, let's say if there is a development of any chip in the country, whether for LED driver or any other matured node, The problem is that for the wafer, as of today, until such time that the wafer fab on a large scale comes to India, we are dependent on getting the wafer either from China, Taiwan, Japan, or Korea, wherever. SCL already has that capability, particularly in the silicon area. They make not those higher nodes like 3 nanometers or 15 nanometers or even 28 nanometers, but there is tremendous demand for standard nodes of 500 nanometers or 180 nanometers, or even coming down to 128 nanometers. If that SCL facility could be productionized, right now they are only typically in a prototype quantity mode, but if they can be productionized so that they can provide wafers to the OSAT companies who can package it and sell it in India. So that is my second ask. The third ask is on the EDA tools. Currently, the EDA tools are provided only to research institutions, the IITs or the triple IITs or the CDACs, and that those are not available to the industry. And when the industry asks these companies like Cadence, Mentor Graphics, or Synopsys, they charge probably 10 to 50 times more. If that EDA tool availability could be made to the industry up to a point, once the design is complete. After that, when we commercialize, there can be some commercial arrangement between these entities, whether CDAC or any institution. Once it is productionized and commercialized, then there can be an arrangement whereby the industry gives adequate compensation to such institute. But until then, there should be some provision for using the EDA tools at similar rates as it is available to the CDACs or the IITs or the other research institutions. So these are the three asks. And my takeaway today from the webinar would be that we have to become a product nation. We have to develop more and more products which are India specific. As many panelists have said about water pumps, solar pumps, etc., which are very specific to India, and we should focus on those. And once we become a product nation, then we will have an ecosystem for deep manufacturing in terms of component manufacturing also develop in the country. Thank you. Ashwini, we can't hear you.
I'm saying, wonderful, sir. We must become a product nation. I take that thought and move onwards to Anuj. Your key asks, stroke takeaway from this session.
Yeah, so thank you, Amritji, for putting in this thing that India has to turn into a product nation. In fact, CIPD was established with the intent and a mission to contribute to turning India into a product nation. And it is slightly unfortunate that the person who was behind establishing CIPD, that is Mr. Mahendra Pratap, one of the co-founders of HCL, is no more today. And we have to take his torch forward. But to turn India into a product nation, one key ask that I have is that we have to support an ecosystem of product development also. In the sense that today, if there is a young engineer, a young a budding startup intending to do a product design, electronic product design, they have to depend on the communities of designers which are based out of India. They ask, when asked for a debug or when asked for a solution, the solutions that come from such communities are not local to India. They talk about products and ecosystems which are not yet available in India. So we need to develop an India-specific community and ecosystem where one could reach out, ask for debug and support, and components availability, for example, which components have the right quality rating, quality specifications. And this community is really needed to nurture the grassroots innovation ecosystem in the country, which would lead to those products which could be globally competitive and put India into the product map. India into a map, into a place where it is considered as a product nation. So,
Beautifully put. Appreciate it, Anuj. Over to you, Nishit. What do you think you would like to add to this? Nishit is on mute, so till he comes back, ma'am Savita, can you take foot?
Thank you, sir. So my takeaway is like for this, I agree with you. Lock-in for the product which is required in a mass scale. That is that can be focused. And for a CDEC, like we have to do more in a design infrastructure support, like for forming a national EDA tool grid for remote access to centralized facility, to EDA tools for chip design activities for startups and MSMEs, like IP core repository for flexible access to repository IPs for SoC design activities, MPW prototyping support for fabricating the design in MPW manner at semiconductor foundries, and post-silicon validation support for fabrication of ASIC and silicon bring-up activities.
Ma'am, you have actually covered it beautifully. Product innovation pitch on a mass scale, national EDA tool grid, expanded for startups and MSMEs. I think that's what Mr. Manwani also mentioned, so it's a common voice coming up. Repository for the support and the design that are coming in, MPW support, and post-silicon validation support. So he actually covered a fair breadth in it. Nishit is not there, but at this stage, I would like to invite Mubarak, Mr. Mubarak, if you can turn on your video and audio, great. We must have Mubarak here. So timely, so well planned in by Elsina teams. They knew that there would be a question that would be asked of an EDA major like Synopsys. So Mubarak ji is from Synopsys, and you heard what the asks were on your EDA tools. I know your global will take away whatever is left on your scalp. But on that note, back to you. Your audience, let's hear from you.
Thank you so much for having me here. It was actually total surprise that I've been invited to this, the two into the panelists. I told Elsina Rashika that, okay, I will be part of this webinar. And then she gave me a link and I joined, and I see myself in the panelist. And my fingers were crossed, expecting not to expect that a question from Dr. Lakshmini or somebody that I've been in this. Anyways, it's honor to be in this group. I heard everyone. As a EDA company, by the way, my name is Mubarak for people that who don't know me. I've been into semiconductor industry for 24 years. 15 years into corporate side and 10 years into startup. I had my own startups. And then I recently joined Synopsys as a strategic business executive here, where I will be actually talking to more of the government entities to see how I can, or how Synopsys can help them both in terms of the product development or any of the programs that they are actually rolling out. Okay. Apart from that, I will also be involved in one good thing that I heard from the panelists is that about OSAT ATMPs, right? So wanted to bring out that yes, Synopsys has solutions to help to increase your yield in OSAT and ATMP vertical as well. So that's about the Synopsys. That's about my little introduction. To answer one question, which Mr. Manwani asked, right? How EDA tools can be available, right? So I wanted to understand more in specific because large companies have the access, startups have the access, academy have the access through CDAC, C2S, and DLI, BLI programs. They have the access. Thanks to MIT for providing their platform. But I wanted to understand which sector of industry Mr. Manwani is trying to highlight here where they need EDA access at reasonable rates?
Well, both in terms of like PCB design side, there are EDA tools that are available, and if you get a commercial license for multiple use, then those licenses are at a very high fee, while to a research institution, it is given at a much lower rate. What the request was that until the product is commercialized, whether it is a PCB design or software development design, until then, if those EDA tools could be available at a low cost, so that and multiple users availability, then it would make the design that much more or that much less expensive at the initial phase. And once it is commercialized, then no entity would hesitate paying whatever the
Yeah, makes sense. Makes sense. This is something that probably as an ask, a EDA company can put forward to MIT as well in their DLI.2 as well, where we as an entity can help all startups, all these companies in terms of tools, not only tools, IP, solution, everything, and services, everything. And once they are out with the product, maybe 2 years or 3 years down the line, when they are commercialized, or they have raised funds like Series A, B, C, whatever you call it in startup lines. So probably they can get into a different level of tool fee, where not only we are at loss, but we have made an investment which actually gives us the returns after 3 years, right? So that way, yeah, this can be considered.
Mubarak, Synopsys is a company I tremendously admire. I think I know some of the moves that you are making in the EDA tool dissemination, and they are pace setting. I know you as a leading EDA vendor, and such openness can reap rich dividends back to both your organization and to this nation. Great. I think is Nishit back online, or he's constrained? So I'll take.
No, actually,
we are now
Nishit has
running.
been called by the secretary, sir, so he's not there online.
Okay, so I will take the liberty of summarizing the meeting from my side in a wrap up. We are bang on time, so the key messages, as everybody's said. Mr. Manwani, what can we do to make India a product nation? What can we do to leverage resources like SCL for the larger good of the industry? Okay, Anuj, how can we bring more functional innovation aimed at end market to add to my concept of adding latent strengths to the product design from the point of view of securing that market from competitive tsunamis, and to make sure that it creates an India chip portfolio. To Nishit with his path-breaking innovations in the SMDP program, the Special Management Development Program, with EDA tools proliferating across the nation. A special thanks I must give to Synopsys. With their open-mindedness, they are actually one of the more generous players driving this innovation across the market. It should be really worthwhile for our future communities in this space. Savita ma'am, for your ideas on the National EDA tool grid for startups and MSMEs, which resonated with something which Mr. Manwani and some of the others have talked of. Building repositories for the content, building up our MBW or multi-product wafer channels for more affordable, lesser volume chips that have to be made in the country, and building up post-silicon combinations. From my side, I would, since I am also part of the group, not just a moderator, I'll put the following thought. I would love to see a session where some of the thought leaders here join together with others to create a brainstorm list of what sort of chips that we want to see evolve, with what sort of functionalities we want to see in those chips, with what sort of unique features we want to add to it so that we can lock it in for our nation. Okay, I think we need that particular sort of a workshop. I would love to see that happen because that would go a phenomenal distance in creating that strategy for an India chip portfolio, which can be the basis for our market-led manufacturing. Okay, so that's on that note, I would like to thank all of you.
So we have Nishit back with us, and also probably Nishit can say something about his takeaway out of this webinar. And post that, we'll be requesting Mr. Raju Goyal, Secretary General Elsina, to give the vote of thanks.
Perfect.
So I think one quick request from all the thought leaders here that we have been debating internally a lot about the volume sets that India should target and can target. Some kind of qualifying criteria for the acceptance of the chipsets for rolling out the PMA and PPO needs to be figured out, right? For example, I mean, in case of e-passport, right, we are figuring out whether the STQC can do the qualification or we have to go for the certifying agency abroad. Similarly, for one of the tender that rolled out a couple of years ago for the Bharat Secure chip, we actually struggled really hard that who will qualify those chipsets, and we, as part of the tender, we actually put the PSA certification from ARM, SAG certification from DRDO and all. So, I mean, some kind of certification and qualifying criteria, if we can figure out for different kind of chipsets, or it can be done by either through security agencies or through the STQC of MIT. So all those things need to be debated and worked out with the support of all of you, sir.
Hear you on it. I think we should have a follow-up session where we should just brainstorm on the chips and some of these processes for the good of creating that chip portfolio. On that note, Raju, you should not be muted. You're the industry voice.
Thank you so much. I have been listening all through, and I think that is what I'm best at in this, on this subject. It's a very, very complex subject, I must say, and I was really, delighted to be part of it. And when I heard most of it, I won't say I heard all 100% of it, but I think the discussion was really excellent. Elsina is basically, concerned more with the manufacturing, side of the industry and of semiconductor. And of course, we are also focusing on the skill development. But it's very clear that unless we understand the market and unless we design, products for this market, our success is going to be limited. So I think this, to that extent, this was a great, session. And thanks, Ashwini, for curating it and for your views on it, which have, really helped us. I must thank Mr. Amrit Manwani, sir. Thank you so much for your participation. And you are the one who is actually taking the biggest leap here. I think it is, even bigger than, the leaps that, Tatas and Microns have taken in your own way. So we are looking forward to your project coming on stream. And of course, my, special thanks, to our friend, Nishit from MIT. Thanks, Nishit, for all your support always and for being here. And I think, your inputs on the certification part are very important. Also, first time I'm meeting Ms. Savita Kashyap. It's really great to read about you, ma'am. You've been doing a lot of work on smart cards, technology and, so many other things. And I think it was really wonderful to have you here on the session. Of course, Dr. Anuj, we've met a couple of times and it's been great meeting you. And thanks for joining this. And I hope we'll have more sessions in IIIT Delhi. Okay, it was a great one that we had last time with Dr. Gaurav Thareja of Applied. And also very nice to meet you, Mr. Mubarak Zahar. I think I've seen some emails from you, and it's very nice that you are showing some interest in Elsina. I'm sure that our group will be richer with your inputs and your support. So we look forward to your continued participation in this group. That's all I have to say. Thank you so much for this program, and we do hope that we are able to do at least one every month of this type of webinar, so that we can take this whole game forward and make India a semiconductor nation and give our contribution as best as we can. Thank you so much. Thank you so much.
Thank you.
Yes.
Thank you, Raju. Elsina has been doing a wonderful job in bringing academia, government, and the industry together. So hats off to you for the effort that you're putting in. And we hope that you would repeat it every month, as you said. So look forward to that.
Thank you very much, sir. I think the team has been doing it, and Dr. Ashwani has been leading it. So we have to thank him also for all that he's been doing. It's really been great. Thank you so much.
Thank you.
Thank you.
Thank you, everyone. Thank you.
Thank you, everyone.
Thank you. Thank you.